In this podcast episode, Lex Fridman engages in a thought-provoking conversation with Adam Frank, an astrophysicist known for his work on the evolution of star systems and the search for extraterrestrial civilizations. Their discussion spans a wide array of topics, from the probability of alien life to the philosophical implications of consciousness. Frank begins by discussing the vast number of habitable zone planets in the universe, estimated to be around 10 billion trillion. This staggering figure leads to the conclusion that if there have been no intelligent civilizations, it would imply that every one of those planets failed to produce life. Frank introduces the concept of the pessimism line, suggesting that if the probability of creating intelligent civilizations on habitable planets is less than 1 in 10 billion trillion, then humanity might be alone in the universe. However, if the probability is higher, it indicates that intelligent life has likely emerged elsewhere in cosmic history. This perspective shifts the focus from whether life exists now to the broader question of whether it has ever existed. Frank emphasizes that the universe has run countless experiments in the form of habitable planets, and unless nature has a strong bias against the emergence of civilizations, it is reasonable to assume that intelligent life has arisen at some point. This line of reasoning opens up exciting possibilities about the nature of life beyond Earth and challenges the notion of human uniqueness in the cosmos. The conversation transitions to the Drake equation, a formula created by Frank Drake in 1960 to estimate the number of active extraterrestrial civilizations in the Milky Way galaxy. Frank explains how the equation breaks down the problem into several factors, such as the rate of star formation, the fraction of stars with planets, and the likelihood of life developing on those planets. This equation has served as a roadmap for astrobiology, guiding researchers in their quest to understand the potential for life beyond Earth. Frank highlights the importance of the equation in shaping the field of astrobiology, as it has provided a framework for scientists to explore the conditions necessary for life. He notes that the equation has spurred research into various aspects of planetary science, including the discovery of exoplanets and the study of their atmospheres. As our understanding of these factors improves, the Drake equation becomes a more powerful tool for estimating the likelihood of extraterrestrial civilizations. The discussion then shifts to the discovery of exoplanets, which has revolutionized our understanding of the universe. Frank emphasizes that the realization that every star in the night sky likely has its own planetary system has profound implications for the search for life. The sheer number of planets increases the chances of finding habitable environments where life could potentially arise. Frank also discusses the significance of the habitable zone, the region around a star where conditions might be right for liquid water to exist. He explains that while the traditional definition of the habitable zone is based on temperature, there are other factors to consider, such as the presence of an atmosphere and geological activity. This understanding of habitability allows scientists to explore a wider range of celestial bodies in their search for life. Adam Frank shares insights from his research on the formation of stars and planets, explaining the complex processes involved in creating planetary systems. He describes how stars form from massive clouds of gas and dust, which eventually collapse under gravity to create protostars. As material falls into the protostar, it forms an accretion disk, where planets begin to coalesce from dust and gas. The conversation delves into the challenges of simulating planetary formation, particularly the interactions between gas and dust. Frank highlights the importance of understanding these processes to gain insights into how planets like Earth form and evolve. He notes that the study of planetary formation is crucial for assessing the potential for life on other worlds, as it informs our understanding of the conditions necessary for habitability. The discussion takes an intriguing turn as Frank emphasizes the role of plate tectonics in the evolution of life on Earth. He explains that plate tectonics has been essential for maintaining a stable climate and fostering conditions conducive to life. The movement of tectonic plates leads to volcanic activity, which releases gases into the atmosphere and contributes to the carbon cycle, ultimately supporting life. Frank argues that understanding the geological history of a planet is vital for assessing its potential for life. He suggests that planets with active geology may have a better chance of supporting life, as they can maintain a dynamic environment that promotes the cycling of essential elements. This perspective highlights the interconnectedness of geological and biological processes in shaping the conditions for life. As the conversation progresses, Frank introduces the concept of technosignatures, indicators of advanced civilizations that may be detectable from Earth. He explains that while traditional searches for extraterrestrial intelligence have focused on radio signals, there are other ways to identify the presence of advanced technology. For instance, the detection of atmospheric pollutants or artificial lights on distant planets could serve as evidence of technological activity. Frank emphasizes the need for a comprehensive approach to searching for technosignatures, which includes both ground-based and space-based observations. He discusses the potential for future telescopes to analyze the atmospheres of exoplanets and identify chemical signatures that may indicate the presence of life or technology. This shift in focus from mere detection of signals to the analysis of planetary environments represents a significant advancement in the search for extraterrestrial life. The conversation naturally leads to the Fermi Paradox, which questions why, given the vast number of stars and potentially habitable planets, we have not yet detected any signs of extraterrestrial civilizations. Frank discusses various explanations for this paradox, including the possibility that advanced civilizations may be rare or short-lived. He suggests that the challenges of sustaining a technological civilization over long periods may contribute to the lack of detectable signals. Frank also highlights the importance of considering the limitations of our current search methods. He argues that the search for extraterrestrial life is still in its infancy, and as our technology improves, we may uncover evidence of civilizations that have existed in the past. The Fermi Paradox serves as a reminder of the complexities involved in understanding the nature of life in the universe and the challenges of detecting it. The discussion takes a philosophical turn as Frank and Lex explore the nature of consciousness and its implications for understanding life. Frank argues that consciousness is a fundamental aspect of being alive, and it cannot be reduced to mere neural processes. He emphasizes the importance of recognizing the subjective experience of consciousness and its role in shaping our understanding of reality. Frank suggests that the study of consciousness should be integrated into scientific inquiry, as it is central to the human experience. He acknowledges the challenges of studying consciousness from a scientific perspective, but argues that it is essential to explore this topic to gain a deeper understanding of what it means to be alive. The conversation raises important questions about the relationship between consciousness, agency, and the nature of existence. As the conversation progresses, Frank reflects on the search for meaning in life and the role of science in this quest. He argues that the pursuit of knowledge and understanding is inherently tied to our desire for meaning. Frank emphasizes that science should not be viewed as a purely objective endeavor, but rather as a human activity that seeks to uncover the mysteries of existence. Frank's perspective challenges the notion that science and spirituality are mutually exclusive. He suggests that both can coexist and contribute to our understanding of the universe. The search for meaning is a deeply personal journey, and science can provide valuable insights into the nature of reality while also acknowledging the importance of subjective experience. The conversation shifts to the role of technology in shaping human existence and our understanding of the universe. Frank discusses the potential for technology to enhance our exploration of space and our search for extraterrestrial life. He emphasizes that advancements in technology can provide new tools for investigating the cosmos and uncovering the mysteries of existence. However, Frank also cautions against the potential dangers of technology. He highlights the need for responsible stewardship of technological advancements, particularly in the context of climate change and environmental degradation. The conversation underscores the importance of balancing technological progress with ethical considerations and the well-being of the planet. As the podcast nears its conclusion, Frank reflects on the future of humanity and the potential for interstellar exploration. He expresses optimism about the possibilities that lie ahead, particularly if we can navigate the challenges of climate change and other existential threats. Frank envisions a future where humanity expands into the solar system and beyond, fostering a deeper understanding of our place in the universe. Frank emphasizes the importance of collaboration and cooperation in achieving these goals. He believes that humanity's collective efforts can lead to significant advancements in our understanding of life and the cosmos. The future of humanity is intertwined with our ability to work together and embrace the unknown.